we will be solving the problem 876, middle of the linked list. The problem statement is, given the head of a singly linked list, return the middle node of the linked list. If there are two middle nodes, we will be returning the second middle node. This is an easy problem and it should not take too much time to understand the problem and then come up with a solution. Let me switch to whiteboard and walk you through a few of the examples to just understand the problem better and then build a solution on top of that. So these are a singly linked list and these null means there are no nodes after that. In example number 1, because we have only one node, so this is what we need to return because there are no middle. In the second example, we have two nodes, 1 and 2. So we have to return the second node if there are two middles. So we will be returning 2 as the output. The example number 3 is straightforward because we have 5 nodes. So we have to return the middle, which is going to be 3. And in the fourth one, we have 4 nodes, which is even. So the middle node will be 2 and 3, and we need to return the second one, so the output will be 3. To solve this problem, the best solution is slow pointer, fast pointer, where we will have two pointers. One will be moving slower than the other one. If you are not familiar with this algorithm, the basic gist is we will have two pointers and both the pointers will be moving at variable speeds. And we will be defining at what pace or at what speed these pointers should be incremented. So to solve this problem, we will have slow to move at one step an iteration and the fast will be moving at two paces or two steps. So let's apply this algorithm to example number 1. So when the program starts, both the slow pointer and fast pointer will be pointing at the same node, the first one or the head of the singly linked list. In the first iteration or in the first loop, the fast pointer will increment or jump two spaces. So it should go to this position. And because there is no node at this position, whatever is the node pointed by the slow pointer will be returned as our output. So this will give us node 1 as the middle node. Let's use the same in example number 2, starting with both the pointers pointing at the head of the node. So the fast pointer is going to jump to 2 and then to null, and the slow pointer will jump by one space. So now it is pointing at 2. Because head pointer is pointing at null, we will be returning the node pointed by the slow counter, which is 2. In example number 3, we'll start with the fast pointer jumping 2 spaces. So it will jump to 2 and then to 3. And at the same time, the slow will be pointing to 2. Because head pointer is not pointing to null, we'll continue. Now this pointer in the next iteration will point to 5. The slow pointer will jump by one space, so now it will be pointing 3. So in the third iteration, there is no node after 5. So we will stop the iteration and return the node pointed by the slow one, which is 3. For the last one, both pointers pointing at 1, fast pointer jumping to 2 and then to 3, and slow pointer jumping to 1. Now from this point on, when it tries to jump, now to 4 and then to null, and then the slow pointer will be jumping to 3. Now because head pointer is pointing to null, we will return whatever is pointed by the slow pointer, which is 3. Based on these examples that we covered, there are two conditions. If head is pointing to null, then stop, or head dot next is pointing to null. So if these two conditions are met, we stop the iteration and return the value pointed by slow pointer. With this solution, our time complexity is O of n by 2 because we are not iterating on each node given in the linked list. We are only doing half because our fast pointer is jumping by 2 spaces. And this O of n by 2 can be represented as O of n. I hope you were able to follow this explanation. Let me show you how this algorithm can be written in C#. Here is the solution in C#. I have created a helper method which will help us iterate for slow and fast pointer. And the first check is to verify if the node pointed by the fast pointer counter is null. If it is null, then I am returning the slow pointing node. If the fast pointer is not pointing to the null, then the next check is to verify if the next node is null or not. If this node is null, then I am returning the next node pointed by the slow pointer. If either of the conditions are not met, I am calling the helper method again by passing the next nodes in the list. So for the slow pointer, I am sending the next node, and for the fast pointer, I am sending the node 2 spaces ahead of each. Thank you for watching this video. I hope you were able to follow my explanation and this solution. If you have any questions, feel free to reach out to me. This source code is available on my GitHub repository. The link is there in the description below. Feel free to check that out, and I will see you in the next one.